Hello everyone, I am Bradley Sward, Associate Professor of Computer Information Systems at the College of DuPage in Glen Ellen, Illinois. And this video today is going to take a brief, in quotation marks, review of Introductory C++ programming. So this is basically for my advanced C++ programming course. This is not a replacement for any of the videos that you should watch from my CIS 2541 video series. This is basically just a review and, basically something to catch you up if you've taken other languages before, if you know Java, you know Python, just to kind of take the same logic and the same understanding of if statements and for loops and whatnot and arrays and bring them over and make them work in the C++ language. So I have Visual Studio working on this thing. It's brief as in quotation marks, obviously, because I don't know how long this is going to go, but I'm basically going to cover as quick but thorough review of everything that you need to know to get going so we can get started with pointers and object-oriented programming for this course, Advanced C++ Programming, next week or the next class session. So I am going off of the Gaddis book, the grapefruit book. I think it's a grapefruit. I don't have the book in front of me. 9th edition Gaddis, that's what I'm going off of. I'm basically going off 8th edition notes and that sort of stuff because our curriculum doesn't necessarily cover a lot of the stuff the 9th edition has right now, like lambdas and things like that, more advanced things, algorithms and such that we're going to be pushing, but we have to do that in the next year or so with our curriculum. So chapter 2, Hello World, that's where we're going right now. I have Visual Studio started up here so you can kind of see. I just have a basic one file open. Don't mind all this extra stuff. This is just my generic, basically starter template for everything I do when I'm grading stuff, and it's just Warrior versus Slime this time around. So Introduction to C++. So before we look at the Hello World program, this is actually the smallest program we can write. Int main return 0. It turns red, like, nope, can't do that. No, of course we can. And so this program will run. There it goes. And I have dual monitor support, so I have to always drag over everything. But that's the way things go. Int main is one of the two portable main function prototypes. Has to return something, and the return type basically goes, when it goes over, it returns back to whoever calls the program to run. In the old days, this would be done in DOS or something like, or maybe even in Linux. So it actually returns a value back to the batch file or wherever the program was run from. But in today's modern world, especially today's Windows world, we very rarely pass parameters into a program when we start running it, because it's just we double click the thing. We're not passing any parameters. We're just starting the thing open, and then we go into the taskbar to do the things we used to do. If we wanted to open a file, we used to just type the file name in after, like, open or edit. But now we don't do anything like that. We go in and we double click on the PPT file, or we go in and we open the file from the file menu. Okay, so coming back, that is basically the simplest program you can get. But other than that, right, comments are // or if you want to /*, and that's the block comment. And so there we go with comments. And so we need to include, if I want to print something out to the screen, I have to include IOStream, input output stream. So that handles everything that's going on inside of C in, C out, and that sort of stuff. And again, this should be a complete review for you. So if I wanted to print something out, I go std::, C out, and I go hello world. That's exciting, right? And then I can put an end line for the end line character so it doesn't print on one line. And so there's the second simplest, or this hello world. That's program 1. If program 0 is just getting return 0 to work with nothing in it, this is the second simplest kind of thing. So comments, they call this a preprocessor directive because essentially we're taking the entire IOStream function, or not the function, the IOStream file, and putting everything into, just jamming it into line 5. Because when I hit this line of code and here is C out, I have to be able to find the object called cout, and it happens to be located in here, but pre-processor. We never see that basically the entire file is jammed in there, so when we go to see cout, it exists in our program. We think of it a little more abstractly than it truly is. And so now that we're in advanced C++ here, you do not go, this is something, we do not use the using namespace std anymore. We actually go ahead and use std : in front of everything that we do. So you can shorthand it, but generally speaking now, as more professional programmers, it's a better way of going about doing things to put std : in there. Among other things, it speeds up compiling and linking time, and it just prevents name clashes and things like that you won't see in here in education, but I have actually seen and just kind of lost an hour or two of work trying to figure out why this just name clash occurred when I'm not the one who wrote that code. Someone wrote it 20 years ago, and now I had to dig deep in and go, oh, that's why, because somebody wrote some function or some variable name or something in some namespace that clashed with what std had in it. So there's a lot of stuff going on. Let's say we touch every key on the keyboard in C++, even the tilde and all that stuff. So again, that should not be any news to you. There's our cout as we're discussing. Programming is fun. I personally agree. Hopefully you don't differ with that assessment. And so again, you can get used to doing things like this, breaking things up, HelloWorld, or you could break it up into two separate things here, something like this, hello, world, and because you can chain them together. Oh, programming is fun. The end L manipulator is your new line. Some of you might remember the /n, but this is more standard. This is a more portable way of doing things than that /n. This end line actually flushes the buffer and does a few extra things that /n doesn't necessarily do. So programming is fun. Do not put quotation marks around it. And the fun thing with this font, when I'm allowed to teach this thing in a classroom setting as opposed to online, at least one student messes up, and that's an L, because just the font, whatever the default font is here, that a lot of students sometimes think that's a 1 and 1, but that doesn't make any sense. End L for end line. It's a lowercase l. Use that over the /n. And there's other ones you could do, right? Now that you're at home, you could actually do /a that actually rings the bell. I don't know if I have. Could you hear that? I don't know. I'll have to look later. But that actually hits the bell, basically back in the old days, you didn't have a sound card like you do now. It was just basically just a little tiny speaker, and it would just go eh. And now it triggers the operating system to make a sound for me. The only other ones I truly do, I use /n. I'll use /a once in a lifetime just to teach it, and then there's /t for going to a tab boundary. Include directives. I said we're going to start IOStream, IOManip, and CMath, and CCtype, and algorithm, and vector, and set, and all these other things. We're going to have a ton of include files in here. So I to this day don't remember where every single function that I need, which include file that thing is found in. And what I'm learning is more and more students move off and compute in other programming environments than Visual Studio. I'm learning that they're not even 100% standard. Even like string has slight differences that causes compiler errors when they submit work. It works on their machine, it doesn't work on mine. So for whatever reason you don't put a semicolon, let's say this is part of the fun of C++ programming, is you don't always remember where to put semicolons, because you notice this gets a semicolon, this gets a semicolon, but nothing else has so far. And I wonder, this is always the thing with Gaddis, does it matter here? Unexpected token. This one does give you a warning. It doesn't give you an error that's not correct, that you should not put a semicolon at that line of code. Okay, variables and literals. So a variable. So that's what is a variable? But a place in memory set aside for a specific purpose. So int is generally, there's three basic types we use. Int, we use float, and we use string, which isn't even a real data type. It's not a basic C data type, it's a C++ object standard template library construct. So what does that mean for us here? Any of these kind of things, std string, z, And so just to be safe, I like to include string whenever I know I'm going to be doing things with it, because sometimes we can actually hit a compiler error or something if we don't include it. And so int x on our environment, even though we're working in a 64-bit on a 64-bit processor, our environment, this is 2019, Visual Studio 2019 for me, it is a 32-bit quantity. It's a signed 32-bit quantity, so x is a value somewhere between negative 2.14 billion and positive 2.14 billion. Float follows the IEEE 754 standard for a 1 bit for sign, 8 bits for exponent, 23 bits for the fractional component. If you take the assembly language class with me or somewhere else, most likely you will get introduced to the way decimal numbers are formatted in binary. And strings are strings. They're arrays of characters, which we'll get into later. So we also use character, which is 1 byte of storage, and in C++, char is not defined like oh, that's assigned. For whatever reason, just plain character is not required to be signed or unsigned. It all depends on the implementation. But in our environment here, it is signed, so I can go from negative 128 to positive 127. And the last one is a bool, and that is true, false, 0, 1, set, not set, on, off. And there are others like short and and long and stuff like that, but these are the basics for everything that we use that we use in C++. So usually, you don't always, but a lot of times you make sure to initialize your values whenever you're working with them, because if you try to use an uninitialized value, if I try to print y, what will happen? I will actually get an error, at least on this system, and they go, uninitialized local variable y used. So you got to watch out for that, and because you got to make sure that because otherwise it's just going to print garbage. So now it'll actually print the 1, and it says 1 hello world. Okay. Let's see. Continuing on here, identifiers, just the name of a variable. What do you say? Make sure you use names for things that make sense. These do not necessarily make sense. This is just an example, but sum and total and found and done, these are things that you should be using. You can't use the keywords. There's a lot of them. C++ has a lot. Some you've never, well, you would never in a million years call a variable reinterpret cast, right? So you don't have to worry about many of these, but if and for and go to and things like that, you do have to worry about. Okay, identifier rules, same things apply for almost every language these days. Basically, just start with a letter. You can have numbers as long as it's not the first character, and you can use underscores for everything else. You can read this if you need to. Again, this is a short review. I'm already 10 minutes into chapter 2, so let's just keep on going here. Integer data types. Again, here are all the ranges for the different data types if you're interested. Know your range so you know what you're trying to use. If I'm going to use a number that's in the billions, I probably should use something that can hold that value as opposed to a byte. That's all that kind of gets to. There you can do things on the same line. So my way of doing things is to set up each variable on its own line, because that allows me to set up comments if I need to later on. And once we get to pointers and references and all sorts of crazy nonsense, the syntax can just completely blow your mind out. So, all right, so integer types, literal types, and you can whatever. You can put things into octal mode, you can put things into hex mode, you can do all sorts of crazy stuff here. So here's the character data type again, 1 byte of memory, and so generally speaking, that's an element of an array or an element of a string is a character. And so this gets a little weird here because I can put something in like that, because E is an ASCII character, which if you go look up the chart, it's a key value pair. Whatever E is it 72 or I don't remember what the number is, but whatever that. Oh, actually, will it tell me? If I run the program, it'll tell me. Let's see. Breakpoint 60. Okay, 69. Okay, so that's what I get. Okay, so moving on. Character literals. Again, that's what we're doing here. A literal value is just a hard-coded number, or like in this case, a character. The hard-coded capital E, a hard-coded 2. Okay, character strings. Notice the null terminator. So if I do set up a string, string z equals my name, Bradley, or just say Brad, 4 characters long. I mouse over the thing. You can see there it says const char 5. That means there's actually 5 characters there. The null terminating 0 character is actually there at the end. So just beware of that. That for strings, generally that null terminator is sitting around. And because that's how we know when to stop printing the characters of a string when we hit that null terminator. So basically character arrays, character pointers, that's the old C style of doing things. String type that is part of the standard template library, that's what I'm dealing with here. Completely different way of going about doing things, except under the hood, it probably works out exactly the same. But there's a lot more bells and whistles that string does for us automatically that we don't have to worry about if we were going to use character pointers and character arrays in the C style. Floating point data types, there's float, double, and long double. Float is good to about 6 decimal points. Double is good to 12 or 13. And on our architecture, long double is the same as double. There's no extra precision. Even though the CPU can handle that, we're not in an architecture environment where we can actually take advantage of long double. And so they're always signed. You can't have an unsigned float or an unsigned double. Basically, everything is stored in a form of binary scientific notation. And again, we spend a whole couple hours in assembly language learning how to do that, so you can kind of look at a number and kind of figure out what you're staring at if you're looking at the number in binary. And so because of this, a float is 4 bytes of storage, double is 8 bytes. Every number that exists, all the infinite number of numbers, have to exist, and there's, this standard gives us a pretty good range, but of course, if we only have 4.2 billion numbers that can represent the entire number line, we're going to have to basically cut this short, and we're going to have some error terms somewhere along the line. So double gives us better. Long double would even be better than that if we had access to it, and maybe one day we'll have even better stuff. But the larger the data types, the slower they are. So in gaming, we usually use floats because we don't mind if something's off by a quarter pixel. It's a video game. We can trick the eye, but for simulations and things that are, really need precise measurements, you should use as large of a data type as you can get away with. Again, Bool data type, true, false, 0, 1. Determining the size of a data type, you can use the Sizeof operator. So again, we know, or at least I'm telling you what the sizes of these things are, but if you didn't know, you could go ahead and just set up, cout size of y. And then let me just comment this out. So this should print 4 because float is 4 bytes. And so float and double are always pretty much guaranteed because they're part of a standard. But bool and character and int and float, or int and long and things like that, they're dependent on the architecture. Variable assignments, we already kind of discussed that. Do your best to assign a variable to a value right off the bat so you don't have an error that pops up. Everything has to go right to left. The 2 goes into x. I can't go the other way around. What is the error that comes up? It says identifier x is undefined, and this says expected an identifier. So it does not work. So you have to go right to left. And remember, this isn't Wolfram Alpha. You have to basically solve for the left-hand side. You can't just say, oh, x plus y equals 2, or something like that. That just does not work. I would have to do the algebra to move everything over to make it work. Initialization. Again, this is just ugly, ugly, ugly stuff. 1 per line when it comes to variable initialization, please. Let's see how are we doing here? Okay, almost done here. Nope. Scope. So scoping is a big deal. That's once we start moving to pointers and dynamically generating memory, we take over from the general system here, the general compiler, when variables come and go, basically, when they live and die. So I like to say when a variable gets created, its scope is until it hits the closing curly brace from where it was defined. And we haven't done if statements and for loops where we have multiple scopes, but it's basically I can always move it forward, I can't move it back. So just understand that B, C, X, Y, and Z all die when I hit the closing curly brace on line 18. And so for other reasons we'll show later on that it can die for for loops and stuff like that when you're inside the curly brace. The basic operators, here we go, plus, minus, multiply, divide, modulus. This is integer division. If you do 7 divided by 3, because 7 is an int, 3 is an int, so you get 2. And it throws off a lot of programming students, especially the engineering students, because our whole life we've been using calculators, right? And it would give me 2.33333. But when it gives you 2, everyone freaks out. And that's because there's a difference between integer division and floating point division. And when this is int and this is int, integer division wins out. So I would have to do like 7 divided by 3.0 if I wanted floating point division. So this is what this is basically saying. This will give me integer division, but I have to turn at least one of them into a floating point of some sort to get it to come out with the precision if I want it. Modulus is just a fancy division that takes the remainder instead of the quotient. We use this for random number generators and such and such. Again, commenting, especially if you want me to grade your work and something's not working right, you probably should comment it so I know at least what you were thinking and maybe give you some more partial credit. Or leave comments to yourself for later on, to do, how to fix this up. And so like for me, I don't comment every line of code anymore, but I comment sections of what I'm trying to accomplish. And I sure as heck, when I have to go out of my way to basically hack something together, I put a giant comment to remind me later on when I come back to it why everything looks so horrible, because it's like, oh, I couldn't figure out how to get it working, and maybe now coming back and looking at it a second time, I can clean it up. Single line, multi-line comments, constants. So like double pi of const double pi equals 3.14159265535. That's as far as I remember. And so that's cool because const means I can't go ahead and change that variable like the Indiana legislature in like 1903 or 1904, whenever that was, because it says expression must be in modifiable L value. So there you go. Okay. So I'm learning very quickly this is not going to be a short video, but so be it, right? You can always fast forward or not even watch this thing at all if it doesn't help you in the slightest bit. So you're going to see programming style. I use what's called the Allman code formatting standard, which means curly braces go on their own line, and variables and so forth, you always tab over, you always use curly braces for every if statement and so forth. And I'm going to really start pushing back on you students. We need to have a standard code format. So it's the visual organization of the code. And I always say, pretend like I'm paying you by the line of code. Do not feel bad. Like I said, when I code in Java or JavaScript or other languages, I'll put the curly brace on the same line. I personally can't stand it, but it depends on the language you're using. So I'm in C++. Generally speaking, curly braces go on their own line. And there's a few other rules that come along, and you'll see the way I code over the course of this semester. And that's it for this Chapter 2. Let's move on to bigger and better things, and I'll try to not talk about every single slide from here on in. Chapter 3, user input and formatting. So what am I doing here? So, oops, I don't know how this ended up all the way down here. So cin, that's how I get input. And let me get rid of this. So coming back to here, if I wanted input for my y, I can just do cin, and notice the chevrons there. They go to the right because we're streaming information from the user into the variable. And so in this case, if I want to print out and parrot back, it'd be like you printed, and you would then go y, and then you do your stdn line. So there you go. So no, there's no prompt here. You should always put a prompt, but I didn't do it. And to say you printed 94. So good for me. I made this work. So that's all we're getting at. You need IOStream. C out and cin need IOStream. And so again, you need the variable to be defined before you cin into it. You can't put it on one line of code. And this is generally how things work. It's a one-liner in Python, right? So it's a pain in the butt. But again, Python came well after C++. So you should always put a prompt. So that blinking cursor, you know what you're trying to do, because in that case, it's just blinking. You don't even know, is it working on something or what's going on? And so, and we'll do cin. User input is important, right? If the program just did whatever, it wouldn't really be much of a program. It wouldn't be very interactive if it always did exactly the same thing every time. Some mathematical expressions. This is what I had pi defined for us here. So 2 pi r gets me the area of a circle, and so forth and so on. Here's a border. Here's the perimeter of a rectangle of some kind. Remember PEMDAS rules, parentheses before exponents, which don't exist in C++, then division and multiplication and modulus, and then addition and subtraction, PEMDAS. And so, have you ever seen those on Facebook where you're like, what is the right answer to this? And everyone argues and nobody gets it right because nobody knows math. And that's what this is all. The multiply would be evaluated first, and then this, because when they're on the same level, everything reads left to right. And then you can do these if you want. Associativity, grouping with parentheses, other expressions. Again, like if I don't put the parentheses around this, this will not get me the slope like I intend. So type conversions. So this is a big deal when it comes to what we call implicit versus explicit conversions of data types. And so you as a programmer, you want to make sure to do your absolute best so that all the data types match up as I use them. If I'm going to be comparing A to B, they better be the same data type, because you don't want the computer or the compiler to be taking A and turning it into the same type as B, because there can actually be mistakes. And unsigned versus signed data type. C++ is famous for all these little tricks and rules that you don't know. And even last year, I've been doing C++ for many, many years now. And in class, I got hit by something I'd never seen before when it came to signed versus unsigned numbers, and we all stared at each other for a while till we figured out what was wrong. So just understand, and if you need to transfer from one to another, do it yourself using what we call static casting. Where is this guy? Oh, I guess we're not going to show it. Yeah, typecasting. So use static cast. So the old C style of doing things here was to do it this way, where you would put float in parentheses and the number would be transferred, because 1 is an integer as the way it is written there. But nowadays we use static cast. It's the more C++ way of doing things. And yes, it is meant to be a horrendously looking thing, because your job is to try to minimize the use of this thing, because it's bad form and it's not a free operation. It feels like it should be a free operation, but if it's a variable, then, if you're taking assembly language again, you know how complicated it can be to convert an int into a float or a float into an int. So let's see, coming back here, overflow, underflow, just understand again that if I have a character, unsigned character, and I add 255 to 1, I'm going to get 0. And that's not good. So I probably should use a short or an int or a long or something like that. And some systems will display errors and some will not. And so you have to be careful as we move forward that the data types match up. Okay, typecasting, boom, 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 multiple assignments. Don't start doing this kind of nonsense. Again, I'm paying you by the line of code. If you think simpler lines of code, as hard as it is to understand, think you might have more lines of code, but if it's simpler statements, the logic works out. Because I've seen plenty of times where everyone tries to fit this, this giant thing on one line of code, and you come back and you're like, what does it do? And they're like, I don't remember. And it's like, when did you do this? Oh, 3 hours ago. I'm like, that's not good if you can't remember. But if you broke it up into smaller lines of code, you can read it a lot easier. And again, readability above all else. I was just like everybody else. I used to think, oh, I could be tricky with my code, but it compiles down to the same thing anyway. So why worry about it? Sum equals sum plus 1. You could use plus equals. This is the plus equals, minus equals, multiply equals, divide equals, mod equals, this kind of stuff. You can do plus plus. I think we'll see in a future here pre-increment versus post-increment. And then also here, when it comes to formatting output, we would need to use IOManip. And if you ever get the Jasudis book, I have it in my syllabus at least, the Jasudis Standard Template Library 2nd edition. I think it's 2nd edition. You should spend $30 on Amazon. It's a very well-written book when it comes to everything the Standard Template Library can do. Near the end of the book, chapter 13, 14, 15, somewhere in there, they show you everything that you can do with formatted output using IOManip. And so I can set the width of output because I'm formatting data. And I don't go into a lot of detail with this because in my experience out in the world when I did video game stuff, I was never this deep into it. Someone else would write the code, I would send it in, and it would format on the screen as it was supposed to for me. So set width, set precision, fixed, show point, and this gets challenging sometimes because sometimes it feels like they're fighting each other to do what they need to do. So just sometimes it doesn't turn out exactly like I expect. That doesn't mean it's not following the rules, it's just doing something sort of like when CSS doesn't work the way I expect it to. I'm like, is it me? It must be me because it's not doing what I expect it to do. Manipulators, so let's see, working with characters and strings. So when it comes to input, all the data types but string work out perfectly fine because when I go for input for a string, I can put a space. The space is the delimiter character when you're trying to do inputs. The space tells the program or tells the function that's trying to get input that I've reached the end of the number I'm trying to input, and so it's basically done. But if I do that for a character string, Bradley space Sward, it doesn't work out exactly right because that space could be part of the string. And so instead of using the arrow operator, I got to use getLine. That's all. Just remember, look through this if you need to, but just use getLine instead of that if you need that space to not count as the delimiter. So let's see here, read a single character, cn.get, all this. The cn is a little funky. Input and output in C++ can get a little weird, especially the input. We'll see when we do files. You can concatenate strings, plus equals. You can get the length. Again, it's a standard template library thing, and this is advanced C++, so you'll see that soon enough. More mathematical library functions. CMath header. Sine, cosine, tangent, you could go online and see them. There's a ton of them, and there's some new ones too. C++ 11, C++ 17, and so forth and so on. The language is always updating. There's a 2020 version coming out, I think it's coming out this year. If not 2020, then 21, a new version. COBOL, one of the oldest languages, still gets updated semi-regularly because there's still a lot of COBOL out there in the world 50, 60 years later. So random number generators, we'll do this plenty in our class. And so let's see, how much more is there to go? Hand tracing. If you really want to go into it, you can basically go like the old days and go through your program line by line and just point your finger and write down numbers on a piece of paper. But nowadays we use a debugger, and you'll see in future videos that I'm using the debugger to kind of show you how code is moving around, especially when things break down. How do I find where the breakage has occurred? So this is just an example if you wanted to go through, but I'm not necessarily worried about that. And so also here, case study that is not for today's problem, but again, taking a large problem and breaking down into its component parts. Okay, chapter 3 complete. Okay, so chapter 4 stuff is basically if, else statements. So what does that mean for us? Here are the relational operators. Basically, it all resolves down to I'm checking a number against another number, and I want to know if one is larger, smaller, or equal to the other one. And so here are the 6 relational operators. The only one that's a little weird is the 2 are the equals, because there's a difference between single equals and double equals. That's a big one, remember that. And then not equals requires the exclamation point. Some languages use greater than less or less than greater than, like Excel uses that for not equals. But just remember, those are our 6 relational operators. And so, say what is true, what is not, that is not a discussion for now for sure. And any of the relational operators do work down to a true, false Boolean result. So this is a little weird one. If result is a bool, this one works out perfectly. The relational operator works out, and whether this is true or false, it gets set into result. So again, do not confuse single equals versus double equals. That can ruin your day. That can take an hour or more out of your time to figure out. You're like, oh shoot, somehow that second equals didn't make it in. So an if statement, right? So if it's raining, take an umbrella. If it's cold out, wear a coat. And so this is a flow chart for something like that. So do something, basically if I do something, if something is true, that's just a plain old if statement. If that if statement is false, I won't do anything. Or in this case, I can do more than one thing. So if statement, and statement to me is always a code block. If b equals true, cout, it's true. Something like that. And just to prove it here, it prints out it's true, like I'm expecting it to. And so just to reflect what happens if this is false, obviously, if not fuzzy, false, it won't print anything at all. And it's still waiting for my key and just waiting for the input because, of course, this is a false statement, so we don't do the code block and we follow through. And so we have to understand this, that whatever goes in whatever goes in here, the conditional part of this, which goes inside of the parentheses, must resolve down to a true-false result. And that's a little tricky because in C++ at least, 0 is considered false, and actually anything else is considered true. So say don't do this, and say don't do what don't does. And if I did if 7, it'll print out it's true. And that's because any non-zero result is true. So just keep that in mind. Other languages, C# and Java and so forth, that is a big no-no and you'll get a compiler error, but it's not a compiler error in C++. And so if, so just going through if, and so that's all there is to it. This must resolve down to a 0 or a non-zero result. And the compiler will tell you if you can't get there from what you got. Let's see, so always use curly braces with me. Always do that. They like to cut this down just because, it's a PowerPoint slide. But to say, trust me on this, if you always put curly braces, you will never have problems, especially if you have nested if statements and all sorts of crazy stuff that comes up over time. Say it's all about consistency, readability, and just making it so I don't have to think about the formatting. My job is to think about the thousands of variables that are running around, and I have to maintain them and make sure everything's working out appropriately. So expanding the if statement, so I can put any number of statements inside the curly braces. It's a block of code, and it only gets executed if the conditional is true. So else, right? So if this is the true portion of the if statement, I can have an else that pops up. Nope, Chuck Testa. How old does that mean? But anyway, so this comes out as nope. It prints out? Come on, help me out here. Prints out. It really does. It's up here. There it is. Nope. Because this is B is false and false is not true. And so this is one of those things. If I see an if statement and just an if statement or even an else if, which we haven't talked about, we could go down 0 code paths or we could go down 1. Because like in this case, I could go in here, but maybe I don't. So I could do 0 or 1 things when it comes to what this if statement does. But whenever I see the word else, I know I have to go down exactly one of the paths. Because if I don't go down this one, I got to go down this one. So if I see if or else if, 0 or 1, and if I see else, I have to go down exactly one path. So if this or else do this. So if this, if that, so forth and so on. If mod 2, even or odd, you can look through that if you really want to. That's not the time for this. Nested if statements. This is where things can get tricky if you don't use curly braces. Because you're like, well, what if there was a second statement I wanted to do inside of here? If true, I don't know, I'm just right, just to have something. And it is true, right? Yeah, look at that. It is true. But like, if I don't have the curly braces, how do you know which if statement or which statements go with which portions of the ifs and elses and else ifs and all the crazy stuff? Because I could just put everything on one line of code. And how readable is it? Obviously, that's the most unreadable nonsense you've ever seen. But you got to watch out for that. And so always use curly braces and always tab everything over every time. And you never have to worry, especially when you later come back and you add a second line to an if statement. You don't have to worry, is that statement going to go to the correct if or not? So here's here is some nested if statements. This is not for us to discuss right now, but you can see how complicated it can get. If this if goes inside of this if, and if this if is false, it comes down here to do this. So, and again, in here it shows you that it gets a little easier. You can reduce this code down. But again, use proper indentation so you know which statements inside which blocks go with which ifs and which elses. So again, if, else if, else if, else if, else if. So that's something like for grading, 90, 80, 70, 60 grade scale. if the test score is greater than or equal to 90, you got an A. If it's, so what happens if this is false? Then your score is less than the A range. So it could be, in this case, if this is 90, if this is false and I work my way down to this else if, the score value must be anywhere between negative infinity and 89.99999. And so, without getting into too many details, students kind of screw up on that kind of detail when they make a super conditional if statement. But because of the way this works out, logically, I know if I fall through that the test score has to be less than the A range. And then say if, else if, else if, else if, else if, else. So if it's not an A, not a B, not a C, not a D, not an F, well, then it had to have been invalid range. So it had to basically, in this case, it had to have been a negative value because there's nothing to say that there's an error above 100 or above 110 or something like that. So Boolean, say flags, that's usually what we set for Boolean values. We'll see this in future lectures, even probably in this stuff, where you're just going ahead and saying, okay, if done, like for a while loop or that sort of thing, I'm going through an array trying to find a value. Is it in there? While done equals false. Continue on doing something. So again, we'll see this in the future. Just understand that when it comes to this. How many slides are there? Oh my goodness. Okay, so when we're combining if statements together inside the same conditional, remember double ampersand, double pipe, and then the not. I try to avoid this at all costs. I will try to push you toward that as well. But notice there actually is a difference, just like there's a difference between single equals and double equals. There are differences between single and double operators for and or. Those are bitwise operators when they are single characters, and when they're double, they're logical operators when it comes to if statements. So stuff like this, if you could put this inside of an if, inside of a while, inside of other, any kind of structures. This just drives me crazy. Why would you do this to yourself? If this is not greater than or equal to z, do the work and just say, okay, if x is less than z, flip everything around, do the use De Morgan's law to do everything properly. So let's see. If this is true and this is true, do this. Otherwise, do this. Okay. If this is true or this is true, do this. Otherwise, do that. So for an and statement, both of these have to be true to get here. Otherwise, if one or both of these are false, I get to here. And for an or statement, if either or both are true, I get to here. But if both are false, I get myself to here. Let's see here, checking numeric ranges. So we'll see this with loop structures and whatnot. How would I know if a value is in a given range? And you can see you use an and if you want to see if something is inside of a range. Use an or if you want to see if something is outside the range. And coming back to the whole De Morgan's law thing, when just the way logical Boolean operators can be flipped around with nots, you would see that this is actually, this is not actually 100% accurate. There's a typo in the Pearson guide here where, let's see, can I go in here? So less than or greater than or equal, the opposite is less than. It won't let me delete because I got to enable editing. Oh, goodness gracious. Isn't Windows fun? There we go. And so the opposite of greater than or equal to is less than. The opposite of less than or equal to is greater than. So these would be equivalent statements. You flip the signs and you flip the ands to ors and ors to ands. And notice this does not work. This is a big one here. A lot of students will try this when they're starting out. And the reason it doesn't work is, remember, every relational operator resolves to true false. Boolean. It doesn't do both. This would resolve to true or false. And if this is resolving to 0 or 1, 0 will always be less than or equal to 0 or 1. This would always be a true statement. It'll compile, it'll run, but it'll always be true. And you'll be hitting yourself going, what is going on here? And that's because you have to break it into two separate parts like you see up here. Menus. I guess no worries about menus. Validating user input. As you become a more professional programmer, it is more and more important to validate user input because you have to make sure that the user put in what they're supposed to and they're not just trying to screw around you intentionally or not. So input validation, we can use loops and loop structures, while loops, to make this work. So we'll talk about this at a later time as well. comparing characters. I'm going to say like it just uses ASCII values, just like 2 is less than 3, lowercase or uppercase a is less than uppercase b, the ASCII 1 is less than ASCII 2, so forth and so on. So you can go ahead and try everything out if you so choose. And so just like how do the words get organized in the dictionary, that's how things are organized for strings as well. Mark would go before Mary because the M's are equivalent, A's are equivalent, R's equivalent, but the K goes before the Y. Conditional operator, I like to use this every so often, but this is not the time to be talking about that. It kind of takes an if-else if and turns it into a one-line statement. Look at it is complicated, but it is, at the end of the day, sometimes it's useful to do. Switch statement, I'm right now saying, I go back and forth on this, but Python doesn't have the idea of a switch statement, and so every so often I go, I'll try a switch statement. There's no easy way to do something where it's if, else 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 if, and then an if or an else. There's no easy way to do that in pretty much any language. And so in Python, you would basically have to do if, else if, else if, else if, else if, else if, else if. But here you could use a switch statement. You could see this here. Let's see if I can make it a little bigger. So you can see instead of having if, else if, I can just say if it's an A, do this, if it's a B, do that, if it's a C, do this, and if it's none of them, do that. And so it's basically just a fancier, more complicated if, else if structure, and there's more rules to follow because you have to have switch, you have to have break, you have to have case, you have to learn all these keywords, and you can't, and because of the way variables scope, you can only scope them once inside of the switch statement. There's just stupid complicated rules. So for today, let's just say don't use it. A couple more slides here, right? So let's say switch, 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 break. We'll see this when we do this in other ways. Break gets me out of a switch statement, gets me out of a for loop, gets me out of a while loop. Very useful stuff. Break and default, switch, switch, switch. More about blocks and scope. And say we'll discuss scope later on once we start newing up memory like crazy. New, especially when we start doing our own vectors and our own linked lists and stuff like that. You'll be newing up memory like a pro. You'll be dynamically generating all sorts of stuff. And that pretty much covers, and one little stupid thing is to watch out for variables that have the same name. Pretty easy stuff there. So, because it's weird, because you could do something like this. You could say bool b, and then you could say bool b equals true. And like when I'm in here, well, which one am I looking at? If I just, if b is equal to true, or if b is equal to false. And so, I don't know why languages let you do this, but there you go. It compiles, it succeeds, but make sure you name your variables different things. I have, it's like one of those things, I've never named my variables the same thing ever, because all it does is cause confusion, and if someone else did that to me, it would take time to think out what they're doing. So don't do it, and then you don't have to worry about that kind of stuff, but it is allowed. So every so often I see a student do it, and a lot of times even they are not doing it intentionally, it's a complete accident, and it takes time to figure out what's going on, and once we resolve that issue, everything seems to magically work. So that's the end of chapter 4. Let's move on.